This is Zena, down at the end of Cornwall, quite literally at the end of the world. We've come here, a few colleagues and myself, for a day to measure the weight of the Earth using a pendulum in a mine.
In 1828, George Biddle Airy and William Ewell decided to come down to Dorcoth to carry out an experiment to measure the weight of the Earth. They were eminent scientists at the time. George Biddle Airy, the rising figure at Cambridge University Observatory, and William Ewell, the master of Trinity College. Their experiment seemed simple. Take two pendulums, one attached to a clock and the other inside it. The two pendulums are swinging at different rates, and you are trying to find the time when they're swinging coincides with each other. But it got complicated. You had a setup on the top of the mine above ground level and one inside the mine. The pendulums are swinging at different rates, and by finding the differences between the different rates of swinging above the mine and below the mine, you can find out the weight of the Earth.
We have a number of top-of-the-range surveying instruments for the experiment. We've got an alidite here, which is a type of compass that you can also sight through as well. So we're interested in sighting marks on our pendulum and our regulator, which will join as coincidences. So that's going to help. And this is a very small telescope, which is going to allow us the highest amount of precision as we do this when we look through it.
Cool.
Is this going to be an issue? How the
No, we're going to be, the clock will be here somewhere.
Yeah.
Yeah.
Okay.
And we'll put pieces of wood across here.
Okay.
The pendulum suspension is adjustable for angle.
Yeah.
We build a floor, throw some flat timbers
We
down.
can piece of that 2-4,
Yeah.
2-6 down.
Yeah, chuck that on there. If everyone's happy for it to go here.
What are you thinking, guys?
Yeah.
Yeah.
Right, so we're about 230 metres down below the surface, down here in the mine. The pendulum is being set up by our mine engineers who are erecting it and also putting in our regulator. And before long, we hope to start making our experimental observations.
Yeah.
Paraffin lamp, you like it on the table,
Yeah.
just as a difference from the light.
I think there are many challenges that we are facing as with every experiment. We can start by the basics, which is comfort. We have a lovely antique chair that was provided us by Professor Sedgwick, but it turns out that we are just too high. We are just too high. We are just too eminent. So we decided to go with a slab of wood. So that's gonna be our number one element of the experiment. Then we have the table, the most important part of the experiment. We did not use it to have breakfast, but we'll definitely have lunch on it. And we not only have to achieve stability of our stomachs, but also stability of the ground. So it has to be made sure that it's very stable on the ground.
You know all about a stable stomach.
Exactly.
So we're here down at the site of the experiment. We've been here all day measuring coincidences using this experimental arrangement. What do we have here? Well, we have a regulator clock with a pendulum inside beating. And out here we have a free oscillating pendulum which is suspended from this beam up here on a knife edge. We're using just candle illumination because the crucial thing here is to try and understand how difficult it is visually to actually perform an observation of this nature. Now, the critical point here is on this pendulum is a white dot. This white dot is aligned with this pendulum here and an observation post behind where you are right now. And on that observation post is a telescope. You look through the telescope at this white dot and you see it moving. When this pendulum is beating at the same time, when it's synchronized with this pendulum here, this black rod here covers up the white spot and it disappears. And what we've discovered is that looking through the telescope at this white spot and watching it disappear is rather like watching an eclipse. It slowly gets smaller and smaller and smaller as the two pendulums come into synchronization, and then once the white spot has completely disappeared, that's a coincidence. And the experiment involves counting the coincidences. Today we found it's taken about 44 minutes between each coincidence, and you need hundreds of coincidences, so hundreds of hours, to produce accurate data on how all of this mass, all of this rock around us, is influencing the speed at which this pendulum is oscillating.